Hello everybody, I'm Nick, and in this video I'm going to show you how you can get started with gRPC, the server side for now, in .NET 5 onwards, because I don't really expect this to change for the years to come. So if you are using 6 or 7, I expect this to be very much applicable still. We are going to focus only on the server side and Unary calls as part of this video, and this will be a series where I keep adding things such as the client, streaming, bidirectional streaming, also performance improvements, tools around it, and so on and so forth. So for that reason, to keep it digestible, I'm going to split it. I'm not really going to explain what gRPC is because I assume if you are watching this, you know the concept and you want the implementation. There are videos that explain the concept in detail, and I cannot really do it justice in a 20 to 30 minute video. I will explain, however, briefly some of the concepts and why I want to use gRPC and where. If you're familiar with that or you don't care, you can skip using the timestamps in the description or in the progress bar to go directly to the implementation. So first things first, what is gRPC? gRPC stands for G, which doesn't really stand for anything, but we think it's Google, RPC, which is Remote Procedural Call. So if you're familiar with something like SOAP, it's sort of the same concept in principle, but it's stepping on different details to provide a better experience. That being said, SOAP as well was claiming to do that at the time, and that didn't really go great. So I don't know where this will be in 5 years. I might be looking at this video and laughing, but for now this is the cool kid on the block, and being backed by CNCF, it has better chances of standing the test of time than those previous frameworks. I personally would use gRPC, at least in the beginning, at least for now, for internal communication of applications. So if I have, let's say, 50 microservices or 1,000 microservices in my system, and some of them can be also used internally, and all of them are REST for now, I think gradually I would start allowing a gRPC way of accessing those. And eventually, all the internal ones, in my opinion, would be gRPC based to allow for the benefits of gRPC. And what are those? Well, the benefit is that it steps on a few ideas such as HTTP2, which supports bidirectional streaming, meaning it's not just a client asks server response transaction, but you can actually have a connection open that goes back and forth with messages without somebody really requesting something. They can just tell each other. And it steps on protobuf as well to define the common contract. And that's great because protobuf is a standard that doesn't really depend on the language. So if you wrote your service in C# and you want me to make a client in Java, for example, to access it, you just give me your protobuf file, which we will see in a second what it is, and I can very quickly automatically generate a lot of that code based on that protobuf file, which is a really cool thing. And then because it's using protobuf, the payload is very much optimized, and because it's using HTTP2 natively and bidirectional streaming, there are claims which actually can be backed by benchmarks, which prove to be way faster than something like REST or traditional HTTP. That being said, it has some limitations, such as you have to use that contract and you have to negotiate the contract before you make any call, because if you don't know what the call looks like, you can't really call gRPC, and we're actually going to see this in practice as part of this video. So there are some things that could be declared as drawbacks, but in my opinion, internally, for internal communication in a company that is using microservices, I think it's a great tool, especially if you really care about performance. So let's dive straight into the code and see what we can do, how we can make a gRPC server, and use a realistic example, because many of those examples they see around are not really realistic. So let's see a realistic one. And here I'm here with Rider, and I'm gonna go new project, and I'm going to name this gRPC service.server. And we're going to make the server of the gRPC application that we're making. So this is the equivalent of your like REST API if you want, or like your web API. And I'm going to select type gRPC service. If you're using Visual Studio, you have something similar to click. So don't worry if I'm using Rider and you're using Visual Studio. And I'm gonna click that and press create. And let's see what this generates. So first, as we can see, we have a protos folder, a services folder, and then the regular startup and program.cs. So very normal stuff for a web API or .NET 5 application. And if you look at the startup.cs, for example, the program.cs, there's nothing fancy about it. It's just making a host with the default builder configuration, and it's using a startup, and that's it. Very basic. And then in the startup, you have the add gRPC call, which will do all the boilerplate registration for our gRPC services. And then it will also map the service that we will be using and exposing through this gRPC application, which is the greeter service. Before I show you what the code in the greeter service looks like, I'm going to show you the greet.proto, and that is the contract that we will be sharing in order for a client to be built that wants to access this application and this service. And let's talk about the proto syntax. First, we have the syntax equals proto3. This is because if you don't specify it, it will automatically default to proto2, and proto2 is a bit of a more limited syntax on the protobuf spec. So this needs to be the first line if you're using proto3, which you should be using. Then you have the option for a C# namespace, and this will be used by the code generation, which will create the service or the server around this file. So this is why we have it here. And then you have the package, which defines where this proto file lives. And if you had some sort of versioning, you could add it here. So this could be package v1, and eventually if you have a v2, you could have something looking like this, but for now I'm just going to keep it here. And then you have the service, and we name it greeter. That's just because the example names it greeter. It's a simple thing that says hello and then it replies back. And here we define a service, and we define what we want this service to do. For example, this is an RPC call. It's a normal call, not a streaming call. If it was a streaming call, we would have stream here. And it's called say hello. So the method that we will call is called say hello as part of the greeter service. And it accepts a hello request and it returns a hello reply. You can see by that how statically typed it is and how clear it is what you're accepting and what you're returning. You can build a client or a server around this idea because it's very clear. And you can see exactly what the contract looks like. We have a message, which is the contract, and it's the same structure for both requests and replies, or requests and responses. There's nothing magic about it. And you give it a name, equivalent to how you would name a POCO object in C#. This is the request and this is the reply. And then you have some types, which is not your regular .NET types. These are a bit different. You have bool, string, you have int32, float, sorry, not float. I said double. Oh, actually you do have float. You have int64, which is long, unsigned versions of all those. You have different types. You have one-off, which makes it more flexible, or maps, and you also have enums. We're going to see some of them, or we're going to see some of them as we go with this series, but I'm not going to bore you with this. What I'm going to bore you with is this number. So this is obviously not a default value, because if it was a string and it was a default value, it would be something like this, which is not appropriate syntax. No, what this is doing is it's telling the contract that in position 1, expect a string which is called, or which represents the name. And if you wanted to have something else, like the age being an int32, you see that it doesn't allow me to use 1, because in position 1, we already have a field with that number. So age would go second, or it can go third or fourth, just to keep some space for some future properties. You don't really need to worry about the ordering per se, but know that these changes, any change you make, so if you have it as 4 and then you change it to 3, this is a breaking change. This is breaking the contract, because it won't be interpreted the way you want it. The moment you assign a number to this in the sequence, that's the number it should always have, and never change it. If you change it, it's a new contract, it's a breaking change. Don't do it. So be very careful. So we're going to see more of this as we're going to build our own profile. But with that, C# and .NET actually run a generator, and I think you can actually say it as part of the processing as well. Or it has already run it, so we can't really see it now, but once we start making changes, we will see it. And that code has created this greeter base, which you can find in the greeter service that is part of the boilerplate project. And if I go in that file, you can see that C# and .NET has generated a lot of code based on that spec file that you didn't have to write. And this code includes everything you need to make the gRPC call, or at least to build the server. You can do something similar for the client as well, but for now we're just focusing on the server. And as you can see, this looks very similar, at least to me, to what you would have with any other service. You can inject your services here, a database, data access layer, or anything, and then you have the request object, which has the name property, the same way we saw here. And if I go in that, this is also automatically generated. We didn't have to write any of that, and you don't really need to know anything about it either. And you didn't have to do the same for the reply as well. This was also automatically generated. Basically, everything was done for us, and we just handed the toys to play with. Now, gRPC, because it's a contract negotiation thing, using something like protobuf wouldn't work without customizing it or using gRPC web to actually make the call. And that's because you need to know what you're calling before you call it and how to call it. And that's all defined in that proto file. For that, I'm going to use something called Bloom RPC. And sorry if that's very small, but I don't think that they allow me to change the size. Yeah, they don't. I'm using the buttons and it doesn't. But this is a client specific to calling an RPC server, and that's done by actually providing the proto file as part of that call. So what I'm going to do is I'm going to choose the gRPC service server and I'm going to run it. And if I was to access this URL from a web client, it will tell me that, hey, this is not actually something you can do. You have to use a gRPC client. So for that, I'm going to not show Explorer. I can close that. I'm going to copy the absolute path for this, and then I'm going to go to the RPC, and then I'm going to find the proto file that I want to use, and I'm going to import it. And as you can see, it shows me the contract with the default value hello, and it tells me that it's a unary call. It detected that because there is no stream here. Unary means client asks, server responds, basically, and that's it. And what I'm going to do is I'm going to say Nick, and I'm going to make that call to the address that is running. And as you can see, the server responded. And if we are to debug through this here by putting a breakpoint, I'm going to run this. And as you can see, sure enough, the field is Nick. The property is set to Nick. It gives me the value I can do something. And this is how you make a client call to the server. Now, you can also do this with C#, and we're going to be seeing that in the future, in a future video. But for now, just know that this is how the server is handling it. Now, this example is cool but boring. Let's spice it up a little bit. And we're going to do that by creating our very own protobuf file. And an example that I want to use, because it's going to play very nicely for streaming as well later, is we're going to use a weather open API to provide some data through gRPC. So I'm going to go to protos and say add a new file, and I'm going to call this weather.proto. And here I'm going to define my spec. I'm going to split to right so we can cheat and copy a little bit, because I don't know everything by heart, and I don't really need to know anything by heart. I'm just a programmer. I just copy stuff around. So what I'm going to do on top of that is I'm going to go to the CS proj, and I'm going to, let me just move this on the side, copy that and change this to weather, because I need to specify to the item group that I have a new protobuf file that is representing a server, so the compiler and the code generation can kick in, pick this up, and make the service out of it. Also, it's very cool, I think, that the only package that you need for any of that is this gRPC.ASP.NET Core, which I think is very neat, actually. So with that sorted, what I'm going to do is I'm going to copy a few things, these first 3 lines, but instead of having greet here as a package, I'm going to say weather. And then the service I'm going to have Actually, let me show you the call I'm gonna make. In protobuf here, I am using the openweathermap.org API, which you can create an API key for and use for yourself if you want. And then I have a query, which is the city that I want to get the weather for. And this is London in my case, because that's where I live. And if I make that call, it returns some JSON and it has a lot of information. So we're going to use that pretending we are a gRPC service that returns the weather to actually return something similar to this. And I think I'm going to just limit it to the temperature and the feels like, but we might actually expand on this in the future. So for that, I'm going to create a service and I'm going to call it weather service. And this service will have an RPC call, which will be called get current weather. Just one of the calls we're going to support. Let me just move this to the side a little bit. And the request contract will be called get current weather. Did I spell this correctly? I think I did. For city request, long nice name, and it's going to return, so returns weather response and then semicolon at the end. And I don't need this anymore. So as you can see here, we have the request and the response object or message, and we need to create those. So what I need to do is say, just copy that message and then the name, and now this is no longer red. And first we're going to have a string, which is the city equals 1, because it's the first property in the contract. And then the other thing I want to have is allow the user to specify the units, because this is what this API calls standard units, but I think I want to have an extra query string parameter here called units, and I want to be able to specify things like standard, imperial, or metric. I'm used to metric, so this should return Celsius. So we're going to use that property as well. And now, because that has on the API level 3 possible values, standard, imperial, and metric, standard, metric, and imperial, we are going to make an enum for it. I'm going to show you very quickly how you can have an enum in a contract. You simply say enum, and then you give it a name, so units in here. And then the first thing will be standard equals 0, and then metric equals 1, and then imperial equals 2. And that's it. If the user provides a value over 2, it will default to the first one, which is standard. And then you just say units, which is the enum we just defined, and we're gonna say units lowercase equals 2, because it's the second field in our object. So city, enum definition, units, first, second. It might seem a bit daunting, but the more you read about the spec and the more we're gonna use it, the more you're gonna understand about it. And then for the response, we're gonna have message, and I'm gonna paste that response here, and I'm gonna say string. Actually, this doesn't need to be a string. This can be a double, because it's temperature. So double temp. How do you spell temperature? Oh my god, I suck. Temperature equals the first one, and then you have double feels like 2, and it's like the pattern to have instead of spaces you have underscores here, or snake case. So now we have the response and we have the request. So what we need to do to actually generate the service, and in fact I can just delete this and this, we don't need those anymore. And I'm going to, oh, another thing I need to do is to actually define my new service, but I'm not going to do this yet because I haven't created it. I'm going to delete, oh, it automatically was deleted, cool. And I'm going to create my weather service. And with my weather service created, I'm going to build the project, because this will run, if you can see here, the proto c.exe, which will look into my protos folder and generate the C# code that I need to create the service side of things, the code generating stuff. So I'm going to minimize that, and now I can say weather service base. And this is what this service generated for me. including the contracts. So I can say override get current weather, and let me do this so you can see it. And let me say return null for now because I don't like that grayed out. So we have an task get weather or get current weather, and then you have the request, and then you have the context, which we will see what it is later. You don't really care about it for now, but you will care about it soon. And now that we have the service, we can actually register it the same way that we had registered the greeter service. So endpoints.map gRPC service and weather service here. This doesn't like it because it thinks it's this. So, I mean, my naming wasn't really on point here. I think I goofed up. It can't really resolve it properly, but that's on me. We could have named this weather provider, which would probably be a better name. But in any case, now that we have this sorted, all we need to do to actually return the weather is to make a call here to get the weather and then return it from the gRPC call. So what I'm going to do to make that very easy is I'm going to go to the startup and I'm going to say services.add HTTP client. And because this is just like any other C# handler, if you want to think about it, I can just inject a service here. So private, not protected, private read-only HTTP client factory, and I'm going to implement that from the constructor, and I'm going to get an HTTP client here equals this, and now I have my client, and all I need to do is get the response. So response text from that API equals HTTP client.get string async, and the call that I'm going to make is here. Now, a few things for this call. First, I want units to be configurable. This API key should not be here to be configuration, or even better in a secret manager, but for simplicity, I'm going to keep it here. By the time you view this video, it shouldn't be usable. If it is, let me know. And also the city should be configurable. So let's string interpolate here and say request.city, and for units, because the three values are equivalent to what the API accepts, we will say request.units, and that should translate properly to what we need. And because I don't really want to create the C# files for this contracts, the API contracts manually, all I can really do is go to this website called quicktype.io/C# and go to generate now, and I'm just gonna paste my stuff here, and it will create the C# classes for me. And is this cheating? It depends on who you ask. I don't think it is. So I'm just copying that. I'm gonna create a folder called contracts, and I'm gonna say open weather contracts. I'm gonna just paste it here. And since this is not really acceptable anymore, I can say JSON property name instead. Okay, so let's rename all of them except for the one who was double renamed. Fine, and now I have API contracts. Voila, I don't really need to worry about them. So all I need to do now for this API call is var temperatures equals JSON serializer dot deserialize into temperatures and response text. And the reason why this is not working is because this needs to be async and this needs to be awaited. And then all I need to return is a new weather response, which is the protobuf contract. Temperature equals temperatures dot main dot temp, and I'm gonna put this here and say feels like this. This is not needed. So now, assuming I did this correctly, I have a configurable way to return the weather via gRPC. So let's run this and go back to the client, and I'm going to delete that and import the new weather proto, which, as you can see, accepts city and units. So I'm gonna say city London, and I'm gonna say units 1, which is metric. And as you can see, I'm getting the weather for London, and that's the actual weather. And if I say Paris and I run this, I'm getting the Paris one. And then if I say Athens, I'm getting, damn, that's actually really good, the Athens weather. So that's a very easy way to create a server and interact with it with a client. So this is how very quickly and easily you can create a gRPC service that returns the weather. You can get the source in the description down below. And this is the example we're going to expand on. Now, you might be saying, hey, why are you using gRPC if you're going to make an HTTP call anyway? And that's a fair question. But the thing is that we're building on top of a faster technology. So anything we do will be faster and scale better. And when this service will eventually return a stream of data as well, it will actually be more beneficial than having a new call every single time to stream, let's say, the weather every second. And also, in like what we're doing in those examples, imagine that we are the weather providers. We're not actually calling any other API, that we are the API. In that context, it makes sense because you are the source of truth and you're returning the data as efficiently as possible. That's all I had for you for this very first gRPC video, focusing on just the server and making Unary calls. The next video, we're going to see more about streaming, and in the video after that, more about the client and performance optimizations. So if you want to see more of this, please subscribe. That's all I had for you for today. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.